Hello all, welcome to Festive Tech Calendar 2022. First of all, a Merry Christmas to all of you and hope all of you have a good New Year as well. My name is Dushyant and that's my Twitter handle at the top. Feel free to follow me on Twitter and we can chat over there, share ideas, questions, thoughts. I'm here to talk about how to design networking architecture for migration onto Azure. So recently, I was working with a customer who is looking to, well, who is migrating to Azure. And this talk is based on the learnings from that experience, the networking, the landing zones, how we deployed all that learning. So the way we will go ahead with this talk is we'll start with a simple set of requirements from a fictitious customer. Then we'll go ahead and understand some of the basics of Azure networking. And with that knowledge, we'll start to design the architecture and present it to the customer. With that in mind, let's go ahead and meet our customer. So our customer is into home automation, like you can see on the animation on the left side. And he's also into home security. You can see the security features on the right side. So by now you possibly have guessed who our customer is, but if you have not guessed, here is Mr. McAllister. So Mr. McAllister is running this new startup and he needs some of our help, and he has kindly listed his requirements here. So what this company has, our customer has, is two on-premises data centers, and they have a connectivity, a switch between those data centers for connectivity. What they need is help migrate workloads onto Azure. And it's essential that we remain connected to on-premises because I think the idea is to remain hybrid, not migrate completely, or possibly keep it for some time until the full migration completes. And the essential bit is all inbound and outbound requests to Azure must use a firewall. Uh, so with all these in mind, let's go ahead and try to understand some of the basics and see how we can meet these requirements. So before we proceed, I must let you know that this talk is based around Azure. So anything I say, like now we're going to talk about Cloud Adoption Framework. So what I'm implying here is Azure Cloud Adoption Framework. And if I'm talking about landing zone, that's Azure landing zone. So I have ignored Azure in many of these headings for now, because obviously the whole talk is based around Azure. So the Cloud Adoption Framework, it's something that's provided by Microsoft, and it is a set of best practices, documentation, and tools that helps us create and implement business and technology strategies for the cloud. What that means is obviously we have a Cloud Adoption Framework documentation here, which I'll not go into details, but that is on documentation on Microsoft, learn.microsoft.com, which provides details on what Cloud Framework is. But I wanted to roughly say that a set of best practices or the learnings that Microsoft has got from within itself, as well as third parties, as well as customers, has been compiled into something called Cloud Adoption Framework. And we also get certain tools to help us achieve that. One of the things Cloud Adoption Framework talks about is the landing zone. Uh, Most of you probably already know what landing zone is, but in case you do not know, it essentially is where the workloads or uh, whatever you're migrating or wherever you're planning to start your cloud journey. So it's the main place where your software lands. Um, it will make more sense as we proceed with it, uh, and we understand the key principles of landing zone. The key principles are networking. We use a networking service, make sure the landing zone stays connected to your on-premises, to the internet, to anywhere else needs to stay connected. It can be using something like Azure Express Route, for example, to stay connected to on-premises infrastructure. The next key principle is identity management. It's important to manage the resources, their identities, their service principals, using something like Azure AD. So you can follow RBAC rules. You can make sure what resource needs access to what. You follow the best practices around that kind of management. The next is governance. Uh, there will be certain policies, like if you say you are a medical devices company, or say you are a financial company, a credit card like following PCI DSS, or you have some PII data. So you need to follow some kind of compliance requirements. So those can be dealt with, automated, enforced, uh, however we like, using something like Azure policies. The next is the security. Security will be key ingredient while being on cloud. You have to be very careful because things can be public, and Azure is a public cloud as well. So security is a shared responsibility between the customer and Microsoft. And we could use something like Azure Sentinel or Defender for Cloud to make sure that our resources and our landing zone is safe and secure. The last key principle of a landing zone is management. Once we have the networking in place, the identity management, the governance, the security in place, how do we manage it? How do we make sure that things are behaving the way they should? They're processing data the way they should. There is no latency in serving our customers, or there is acceptable latency. There would probably always be some kind of latency, but there is acceptable latency. So all that we could manage using something like Azure Monitor. So those are the key principles of landing zone. So how do we go ahead and create a landing zone? So that's the essential bit. And landing zones more or less will depend on the use case. Each customer's landing zone will possibly be very different, very bespoke to what they need. One of the ways of deploying a landing zone is Azure Blueprints. So this is the definition of or the documentation of Blueprint. All it's saying is that it helps teams to rapidly build and start up new environments with trust they're building within organizational compliance with a set of built-in components such as networking to speed up delivery. Uh, all it means is that it's a big set of ARM templates which can be deployed at the same time. And it could be deploying your VNets, your subnets, your gateways, your key vault storage account, whatever is needed in that specific set of deployments. And all of them can be grouped, all the different deployments can be grouped into one Azure blueprint. So I can show you a short example now. If I go into my Azure portal and I go into blueprint definitions. So this thing that I'm doing is actually documented in here on the Cloud Adoption Framework, Azure landing zones, and implementation. And there is small Cloud Adoption Framework Foundation blueprint. And it also says how to deploy that. The reason I'm going for a small one is because it can take quite some time if we try to deploy the other ones. And it'll be a small, quick, just a run through on what this looks like. So we go into our blueprints on Azure portal and we create a blueprint. And there are lots of samples. And we just look for the foundation one, which is what we saw here. Deploy the CAF foundation. So that's the one we're looking for here. And once we find that, we just need to give it a name. Let's just say CAF and foundation. And where do we store it? So I have a few subscriptions. I'm going to store it in subscription number 2. The next is artifacts. We can actually go ahead and see what this subscription plans to do. So these are policy assignments. So there will be policies to say what kind of storage SKUs are allowed, what are the locations for our deployments, what tags should be added, and it will also deploy some resources. So that's the plan of this blueprint. So if we have a small landing zone being created, we could do it with this kind of deployment, the CAF, CA Cloud Adoption Framework Foundation Blueprint. And if we just save that, possibly will take a few seconds to save. There you go, it's saving. And once that's saved, we can assign that blueprint. And we just go ahead, publish the blueprint, and say version 1.0, publish it. So once that's published, we can go ahead and assign the blueprint. And we saved it inside subscription 2. And let's say it will automatically select subscription to where it'll assign it. Location, let's go UK South. We don't have any logs, and here we have to fill some values. And in this case, I'm going to leave it as is, and it will fail because I'm not going to provide the real values here, like the object ID. So I could just possibly just copy this value, or just say, in fact, it's going to fail mainly because the value doesn't exist. And let's see, UK South. We don't want so long. So those are the values, like it will deploy log analytics workspace. So it's asking how long we want to retain data in the log analytics workspace. And many other such things. We could control the whole deployment from here. And once we assign it, it will start the deployments. What I know is this specific deployment is likely to fail. I just wanted to show you how easy it is to go ahead and do it. And once it's assigned, we can go back into assignments and see here, and it will show it's waiting, and it will go ahead and deploy, and it will go ahead and create those resources for us. So when we create a landing zone, we can actually use a blueprint to do all the networking, connectivity, and identity management deployments, which is well and good. And we do get quite a few samples, enterprise scale, small samples from Microsoft itself. Having said so, the Azure landing zone documentation, if you go into that, a real landing zone actually looks something like this. If I just zoom into it, in fact, I don't know if you can see the whole thing. It is quite a big diagram. I'll have to zoom in more. And then we see the scale of the diagram. There's so many resources and a lot of complexity in a landing zone, because it's not only one express route or one virtual network. It is multiple subscriptions, multiple regions, virtual network, DNS, Azure Key Vaults, and many other resources being deployed, possibly domain controllers as well. And we need the policies, the network watcher, and Azure Sentinel, possibly Defender for Cloud for security. So overall, it does become a complex affair, which is where we'll go back to our slides. So we understood how to use blueprints, and we saw the deployment complexity of a landing zone. And this is where customer thinks it is too complex. And at this point, I'm going to talk shortly about my workplace. I work for Fujitsu as a cloud native technologist, and Fujitsu offers a product called Springboard for Microsoft Azure, which is ARM templates, Azure CLI, Azure PowerShell, and Azure Bicep based product, which automates with full code, obviously, and CI/CD, Azure DevOps, and automates the deployment, creation, and management of a landing zone. So if you are an organization and you are planning to migrate onto Azure and you need some help, get in touch with Fujitsu. Having spoken about my employer, let's move back to our journey of learning the basics of Azure networking. The next one on the list is virtual networks. In this one, we'll quickly go through VNets, subnets, and peerings. So this one, I have already created something. So I've already created this test virtual network. And all I wanted to show through this is a virtual network is a collection of subnets. And we can create multiple subnets here. And each subnet can have an address space. Like if you see this one here, this is a CIDR range. So it will have quite a few, 251 available IPs. So all these subnets can have multiple resources as well. The other bit is the peerings. The peerings are quite an interesting thing. So this is where we can connect one virtual network to another virtual network. So if we go ahead and add peering, so we'll need to give a peering name and the remote virtual network details. So what it will do is that requests can flow, or the data can flow from one virtual network to another through these peerings, which is going to be really useful in our journey while deploying our landing zone and helping migrations onto Azure. So that's roughly what I wanted to show about virtual networks. If we go back into our, again, learning journey, the next one is the virtual network gateway. So now that we roughly know what a virtual network is, the next important bit is a virtual network gateway. And a gateway, like it says, it's literally a gateway, that an entrance to the virtual network. But what it is in the backend is actually a VM. We as users, because Azure it's a managed gateway, we don't get to manage that VM. Whatever we set up the VNet gateway with the configuration, the VM is configured in that manner. So there are two types of virtual network gateways we can do. The types are VPN, which is for a VPN gateway, like if we have site-to-site VPN or point-to-site VPN, any kind of VPN setup we have, that will need a VNet gateway of VPN type. The other one is express route. If we deploy an Azure express route connectivity, then that will need a VNet gateway. So this gateway is needed when we have connectivity coming from outside of that VNet or mainly on premises. So when the on-premises data comes into the VNet, it comes in via the VNet gateway, which is a VM. And that VM is connected to a subnet in the virtual network of, well, whichever virtual network has this gateway. And the gateway subnet is the subnet of the VM, or the VM is VNet integrated to gateway subnet. So that's the entry point of data into the virtual network. The next bit is Azure Firewall. Azure Firewall is a cloud native and intelligent network file security. We can quickly go through the documentation. It's without going into full detail. It's again, like there are multiple firewall options, standard, premium, and depending on the requirement we choose, obviously they cost differently as well. Standard is really cheaper than premium, and there is a firewall basic one now. But all it does is it makes sure on the basis of certain threat intelligence, as well as any kind of restrictions, rules we apply, it will allow or deny traffic based on that. So that's the idea behind the firewall. And the final bit we have is connected to on-premises. So now that we know some of the basics of networking within Azure, we now need to connect to on-premises. Remember, our customer wanted on-premises connectivity. So the way we do that is VPN. So VPN can be multiple types, site to site, which is like you have one big infrastructure, maybe multiple virtual networks or something on Azure, connected to another set of virtual networks on Azure. Apologies, that's VNet to VNet. But site to site is more like if you have, say, a Azure infrastructure connecting to on-premises, or one on-premises infrastructure connected to another on-premises infrastructure. So that's site to site. Point to site is when you have one device connecting to a site, like maybe one laptop connected to a big site. And the characteristic of a VPN is that it actually goes over public internet. It is encrypted, IPsec encrypted, but it does go over public internet. But then the next one is Azure Express Route. It's a more expensive service, but the advantage is that it uses Azure's backbone network, meaning it does not go over public network, public internet, as well as it's faster because it just goes over Azure network straight onto on-premises. With all these in mind, we shall go ahead and design the initial architecture. And if you see, the initial architecture looks like this. Let me run through quickly on how it works. So the customer said we have two data centers, say DC1 and DC2, and these two are connected through, or the data flow can be controlled using a switch in the middle. So now that we have a switch in the middle, that switch is where we need to connect our express route. So this is the express route. And the express route connects, if you remember, to the gateway subnet, because the gateway subnet is the entry point into the VNet. So this gateway subnet is obviously part of a VNet, and all the data coming in has to go through a firewall. And we will quickly go into route tables in the next slide, but that's how the data goes to the firewall. and all of this is in a subscription. So we roughly know this is what we will deploy for our customer. We will go back for some customer feedback. But before we do that, let me quickly go through the data flow because this is something I picked up quite recently, and it took me a while to understand how the data is flowing, how the data from on-premises is flowing all the way to Azure. So if you remember the initial architecture, we have data center and then a switch and then the express route. So if you go back, the data starts from the data center, it flows to the switch, and at the switch, it goes through the express route into the gateway subnet, and it goes to the gateway subnet to the gateway VM of the VNet gateway. Now that it has reached VNet gateway, we need to enforce. Remember, our customer's requirement is that it has to go to the firewall, inbound and outbound. So the way to do that is to use something called routing table. And all that does is that the subnet is assigned a routing table, and the routing table enforces that any incoming data from outside the VNet has to go to the firewall. That's the next hop. You must go to the firewall. So this icon over here, that's the routing table icon, and the routing table is forcing the data coming to the subnet to go to the firewall before it can go anywhere else. So in fact, it cannot go anywhere else because the routing table will say the next hop is firewall. So it has to go to the firewall. And once it has reached the firewall and all's good, firewall likes it, it passes our rules, then only it can reach the VNet. And once it is at the VNet, remember we have peerings. And because we'll have peerings, this data can now flow to other VNets wherever it needs to go to. It can flow to wherever it needs. And once it has reached the VNets, the specific VNet, it possibly could be this first VNet itself. But yeah, once it has reached the VNet, any VNet integrated resource, now it can reach those resources. It could be a web app, it could be a function app, it could be a VM, or any other VNet integrated resource. With this in mind, like one VNet paired with multiple VNets, I think we should quickly touch on hub-spoke topology. This is quite widely used topology on Azure and elsewhere as well. The idea here being one of the VNets in this example, the middle one, is the hub virtual network. It is essentially the naming. We do assign specific configurations to that, but it's still a VNet. It's nothing special about it. It's not a special hub virtual network resource. It is a VNet. And the same are the spoke networks. But the way we put them is that one is the center of the hub VNet, and all requests come to this one because that's where we have the firewall. And that's where we'll have our gateway subnet as well, or the VNet gateway. So that means all requests will come to this virtual hub. And once it has reached and met the policies, the security requirements of the firewall, then via peering, it can go to any other spoke virtual network. The advantage here is we need to manage the connectivity on premises or in VNet to VNet connectivity, any kind of connectivity that we want, only in one place. And all the spokes, in fact, we can deploy maybe a new spoke for any reason. Maybe it's a brand new department starting and they're doing lots of their own resource deployments. Then we start a own spoke, and there can be another third spoke down here. But overall, the idea here is there is one hub who is managing all the connectivity, and there are multiple spokes with ideally their own responsibilities, or they could possibly be for deployment, for example, like for DR. Well, I did touch on it. So let's go and speak to a customer. We have come up with our diagram. So let's go and remember our architecture diagram. So let's go and speak to a customer. Let's get some feedback. So now that we're liaising with a customer, the first question is, where is DR? So disaster recovery. We did think of that because we spoke about it. But yeah, good that Mr. McAllister has actually spotted that we haven't done DR. So we go ahead and implement DR, and this is the final architecture. So let me just quickly run through what that means, the final architecture or the DR. So initially we had this one subscription connected via express route. in one region. So the concept of disaster recovery is that we will have redundant resources in another region so that any disaster occurring in this region, we can fail over to the next one. And the way this happens is the second region is also, if you see here, connected to via express route, which is one way to do it. Express route is more expensive. Uh, Depending on the requirements, some customers will choose to go to one express route on this side, but the other region will have a site-to-site VPN, which will save lots of cost, and it will not be up and running anyway because you deploy it or possibly it spins up or gets used only in case of disaster. One of the things to note is that this switch needs to support BGP protocol, which will help automated failover in case of disaster recovery. Otherwise, at this point, when say region one is not working, somebody has to manually say to the switch that, okay, stop going to region one, go to region two. That's where the BGP protocol comes into play. But with that in mind, this is roughly the idea behind the redundant region of or redundant network connectivity region, but we will also need similar redundancy for apps. So the general architecture for our apps will be that all web apps will be again redundant in two regions, region one, region two, and they will, all public facing ones, will have a front door in the front. So obviously we can use other front door features like global CDN and WAF and other things. And any backend database, which possibly Cosmos DB, will be globally distributed across the same two regions as well. Multi-region write may not be multi-region write, but the idea here is it's ready for disaster. Or in case of disaster, we can recover data. Our services do not need to go down. The general architecture for APIs will be APIM backed by function apps, backed by Cosmos DB, and it could be again multi-region, redundant, and we can control this using APM policies itself. Like a certain region is not working, then fall back the request to the other region. General architecture for the databases. All databases can be multi-region. So again, redundant across two regions. Make sure there is a automatic failover set. So if say for some reason UK South goes down, then UK West keeps serving requests. And with all these explained and our architecture diagram, we now have a happy customer. So me talking through all this, and we have a happy customer so quickly, it all sounds too simple. We did skip over quite a few things, so I wanted to quickly list those things that we skipped over. First was ADFS AD connectivity, because we did discuss that they have on-premises infrastructure. So very likely they have ADFS on-premises or some kind of identity management, domain management system. So we could have gone into more like domain controllers, possibly AADDS, which is Active Directory Domain Directory Service, I think. But AADDS, it's a service which I'll possibly need to Google to confirm the name, or you can possibly do it. The next is DNS. We completely skipped over DNS, public DNS, private DNS. If storage accounts need private endpoint, then we'll need private DNS. So those things we completely skipped over. More than two region connectivity. So we discussed on-premises to one region and went on to say two regions for redundancy. But what if the same architecture is somewhere else? Like think about, say we're doing UK South and UK West. What if we need to replicate the exact whole thing in Australia or India or wherever else? Then we need to maintain connectivity between all these regions, which have their own two regions being redundant among itself. So it does become quite a complex architecture. Um, the next thing we skipped over is security. We completely ignored Azure Sentinel, Defender for Cloud, or how do you maintain the security. Also the policies. This we did not discuss in this talk. And the monitoring, Azure Monitor, or understanding how things are running. Although we did skip over, we did go through many of the networking bits, which is what the aim of this talk was. And with that, I would like to say Merry Christmas to all of you. Thank you. I'm Dushyant Priyadarshee. That's my blog post link. So if it's useful, many of these things I'm talking about, I do write few posts about them, which is mainly for me to go back and see that what I learned last time. But if it is useful for you, feel free to go ahead and see it, check them out. This is my Twitter handle. Uh, if you follow me, I'll try to follow you back, or you can feel free to ask questions on Twitter if you want, or share your thoughts, comments, and I'll be happy to chat with you as well. And yeah, thank you very much. Merry Christmas and have a good New Year, everyone.